I'm going to do Leetcode 1431, kids with the greatest number of candies. So we given this problem here. It's basically an array of integers that they call candies. So 2, 3, 5, 1, 3. So we're asked to do, okay, given this number of extra candies, if you take the 3 and go one by one, okay, if I take 2 plus 3, that's 5. Is that equal or greater than the largest among all the numbers in candies? That's basically what the question is asking. You might be intimidated by the description, but it's basically what it is. So let me give it an example again. So basically 2, right? Given the first element, that's a 2. We're gonna give the extra candies. So basically a kid is there has 2 candies. If I give more 3 more, that's basically 5. Okay, now let's compare that among all of the elements in the array. Okay, the 5, is that the greatest? Well, the greatest in this array is 5, right? So this one matches or outpasses the greatest. So it could be equal or greater than. So in that case, you're gonna make a new array that corresponds to this specific position, and you're gonna say true, a Boolean value, if that value is equal to or surpasses the maximum among all. And you can do the same for the next, right? The next one, let me put it in a different color. That's the 3. Okay, if I take the 3 and add the extra candies, that's equal to 6. Does that surpass or equal the highest among all, which is 5, right? It does. Therefore, it's going to be true for that new array. And then keep going like that. Yeah, obviously, the next one is 5 itself. It's going to surpass because it's going to be 8, right? So it's going to be true. And then the next one is 1, but if you take 1 plus 3 is 4. But 4 does not equal or surpass the highest, which is 5. Therefore, it's going to be false for that one. So we're going to put false in the array. And then repeat for the one is going to be true. So you can see here, they're expected. True, true, false, true. That's what they want for the answer. All right, so I'm going to do in Java. So they want a list of Boolean to be returned. The way we think about this problem is basically I'm going to go and find out what the highest element or greatest is among all of them. So that's one loop, one traversal on the array. And then once I got that value, I can do another loop to generate that array of Boolean values because I already have the highest. So I'm just going to take the current value of candies, add the extra candies, and see if it's greater than or equal to the highest I've seen. So let's go here. So I'm going to keep track of the greatest. I'm going to call it a variable, call it greatest, of type int, integer, initialize that to 0 because I know the kids either have nothing or at least 1, right? So it's going to be okay if it's 0. And then we're going to keep track of, we need to generate a list of Boolean values, or an array, right? So in Java, to do that, I can do a list interface of Boolean, but that's the expected return type. And I've just called it result. I think that's what they wanted, yeah, in the description. So I'm following the same name. And in Java, I have to do an implementation of the list, which I can use array list of Boolean with the template type. And then I'm going to initialize that with candies and a primitive array of ints dot length. That's just the capacity. Okay, so I'm going to traverse it. And then for the same deal, a loop traditional with the index variable that will be changing from 0, 1, all the way to n minus 1, where n is the length of the array. So as long as that is less than the candies dot length, we're gonna keep on going after each iteration increment, then check, increment, check, so on. As long as that is true. So, and then after that, we're gonna return here at the end the result anyway. So what we're gonna do in the loop is figure out what we have to put in the result. But like I said, I have to do 2 passes here. So the first pass, just figure out, okay, this is the simple problem of figuring out what's the highest number among all of them, right? So that's easy, the highest, right? The max value. So if I have seen, if the candies at I, if that is greater than the greatest, that means the greatest should now be the candies at I, right? So that's the max value of an array problem. So that's going to take care of finding out what the greatest is. Now, we're going to do another pass to generate the result array. So I'm just going to do int I equals 0, the same deal. Basically a repeated thing. Now the second pass is basically gonna take the result list and gonna add a new value. This is how we do in Java. You'd say dot method dot add and then the value and put a semicolon. Now the value is gonna be what? Okay, we got candies at the position I. That's the number of candies for one child. Now I gotta take that, add the extra candies, right? That's the variable extra candies here. That's an int. So you take that, you add. Okay, now that value, is that going to be equal to or greater than the greatest? So greater than or equal to the greatest. If that is the case, it's going to be true. And it's going to generate a true value that's going to be put into the result. Now, if that's not the case, it's going to be false. So the false is going to go into that item of the list. And there you go. 2, 3, 5, 1, 3. So if you add, that's 5, add 3, 6, 8. That one is 4, it's less. And the other one's 6. So all of them are greater than or equal to 5 except this one here when you add the 3. Right? So true, 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 false, true. Okay, type complexity of this. Even though I have two loops, they're separate, they're not nested. So you can think of it as O of n, O of n. O of 2n simplifies to O of n for the times complexity. Now I'm keeping track, I'm recording a new list of as many values as I have for candies. Therefore, the space is going to be O of n for this. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right, thank you so much, and I'll see you in the next one.